Well, today our speaker obviously is J.R. Boisclair. My bastardized, is it Boisclair? Boisclair?
Boisclair, Boisclair,
Boisclair,
Boisclair.
Boisclair. Okay.
Depends on how gringo you are.
Yeah. JR has a background in finance and operations, but he's been an audiophile for 35 years. He was introduced to Wally Malwitz by mutual friend a while ago and spent several years as Wally's production assistant focusing on his electronic products. Wally paid JR in audio products, but more importantly, he paid him in knowledge not only of analog setup, but also acoustics, psychoacoustics, and even speaker design. After Wally's death in 2018, JR had been working with Wally's son in terms of Wally's estate, and together they decided to resurrect WAM Engineering. And since then, WAM has now matured with access to material scientists, cutting edge lab equipment, and computer analysis to become the monster analog analytical powerhouse that it is. And I guess JR can talk a little bit more about some of the kinds of things he's currently doing in services that WAM Engineering provides prior to getting into his talk, which today is about audio myths in relation to vinyl playback and acoustics and bass propagation. And with that, I will hand it over to JR.
Thank you, Jim. Yeah, I'm gonna handle today's. Usually with these presentations, I've got a slideshow and there's a cadence to it. But today I've just got a list of what I've called myths that I'd like to address if we can get through all of them, because I think they're interesting myths and they stem from well, one, I'd say, difficulty that most everybody has, including me, in being able to identify when we make a change, any one change to our system. Doesn't matter what it is, whether it's a component or changing tonearm height or alignment of the cartridge. We have difficulty identifying how many variables we've just changed. And then when we hear a difference, we ascribe what we hear to the one thing that we're familiar with, not realizing that we've actually made multiple changes and making a decision on what you did change, something that you changed, whether it's again a component or an alignment. It almost never is it a univariate change. You've changed many things, and so it's a complicated world that we live in that involves deep understanding of electronics, acoustics, psychoacoustics, and mechanics, certainly in the realm of mechanical transcription, which us audiophile folk live in. And so it's easy to not truly understand what you've just heard or why you heard it, so that you can then make a good decision about what to do next, right? So and yes, Stephen, and physics. So yeah, so I'll go through a few things, a few of those, well, I would say traps and misunderstandings, and then of course the media and many manufacturers play into the oversimplification by telling us, well, if you buy my XYZ product, I've solved the problem you didn't even hear about yet. Okay, and it doesn't make a whole lot of scientific sense, doesn't quite compute out, but we can hear an improvement, and so we take it. Well, look, I want all the improvements just like you guys do, but I want to know why. Because if I know why, then I can provide some discipline to the approach that I take to constantly take my system from where it is now to my experience where it will be tomorrow. All right, because almost very frequently, when we make a change in our system, we get a net improvement, but we don't realize what we just lost. Because we're so enamored with this new enhancement, new thing, and we don't realize, oh, we just lost something. But the better we can understand the mechanics, the electronics, the physics, the mechanics at play, the better we can go about our decision-making process. So I will go through a few topics, and I invite questions. And certainly, Jim, interrupt me if they're kind of loading up here on the side, if they're coming through the chat, or if, I don't mind being interrupted. You might have to remind me where I left off, though. Okay. So, does that sound fair? We'll take this kind of ad hoc approach. All right. Now, so I shared two main areas where I feel like I've got some level of competence that I feel like I can add something to the conversation. And one is, of course, in mechanical transcription, turntable side, right? And then in bass propagation. So let me go into the analog for a little while, and then maybe I'll switch over to the bass propagation side, and then I'll flop back and forth if you don't mind. But if it gets confusing, just tell me. I'm not, when people hire me to come to their home to work on their analog system or their acoustics or bass propagation, and I tell them, and I certainly tell people who call and want to ask me questions about my products, the Wally tools. I tell them I'm not interested in helping you improve the sound of your system. I'm not interested in improvement at all. Improvement is cheap and easy. I'm interested in optimization, which is to say that there's a specific set of goals we can aim at and measure for and know whether we've hit them or not. Optimization is what I care about, not improvement, because improvement doesn't suggest doesn't carry with it the implication that we've taken a disciplined approach to not leave certain variables lost in the mix. Okay, so it's but then the question is, okay, well, what can we measure? What can't we measure? Well, there are many things that we can still hear that we're not quite sure how we're able to measure it. There's other things that were just a few years ago, certainly on, say, the cable side and power cable side, that we used to say, well, you can't measure it, therefore how can we hear it? But we were hearing it. Now people like Garth Powell at AudioQuest have come up with ways to measure things that, very interestingly, now we weren't looking at measuring it in those ways before. Now we're finding new ways to measure. As long as there's an interest in getting to the bottom of this thing, then there'll be people like Garth Powell and others who will find ways to measure what we're hearing. And of course, it needs to be repeatable, right? I might be able to do it today, but I better also be able to do it tomorrow and the next day and the next day after that and get the same results. All right, so the first myth I'd like to talk about in the analog, and it's in the analog realm, and I'm kind of on a crusade right now to get people to stop referring to changing their arm height, their tone arm height, as a change in VTA or SRA. Because technically, when you raise and lower the arm, yes, you're changing VTA and SRA, but that's not what we're hearing at all. Because when you raise and lower the tone arm, which, by the way, on most tone arms, you can only do about plus minus 1.5 degrees. Okay, plus minus 1.5 degrees. What you're hearing is vector forces changing. Those characteristics totally dominate. And how do we know this? Well, how do we know it's not SRA or VTA? Because when we change SRA and VTA at the head shell, it doesn't sound anything like we're told to expect and what we do here when we raise and lower the arm. You know, the old trope that when you're changing VTA, you lower your arm and eventually bass will become more abundant and high frequencies will start to roll off and then bass will become muddy, right? Well, what you're doing when you lower the arm, you're lowering your SRA and VTA. Well, that's not at all what you hear when you're changing the head shell. Now remember, most arms will only give about 1.5 degrees down, right? But the average VTA change to get to optimal for the average cartridge is 9 degrees. 9. Okay, I can show you what that looks like. It's a lot. It's obvious from across the room. And it doesn't. And when you change the VTA at the head shell, it doesn't change the bass, the tonal characteristics, except maybe it makes bass a little bit more tight, right? A little more solid, a little more bass grip. But what you get is just more clarity and separation of instruments and better layering and a larger sound stage. And it just sounds more like music and less like you're listening to a stereo. So what you're doing when you're lowering VTA, you're decreasing harmonic and intermodulation distortion. And this has been studied decades ago and seems to have been forgotten by cartridge manufacturers. The average cutter head, so whether you got a Neumann SX68 or SX72, or you got the Lyric or the Scully Westrex, after you take into account lacquer springback, their modulation angle is between 15 and 20 degrees, with most of them at 18. But most of our cantilevers are up at 27. Most of our VTAs with a level head shell under stylus drag is up at 27. So that's why almost all my clients get these wedges, right? 1 degree, 5 degrees, 7 degrees, whatever is needed. So when you raise, I'm not saying don't raise and lower your arm, but don't think for a minute that what you're hearing is a change in SRA and VTA, because it actually takes quite a lot of angular change for the characteristics of optimal SRA and VTA to start manifesting themselves. It's not a very sensitive parameter at all. And we started seeing that in our early work in finite element analysis. But a lot of people say, well, they can change the arm by 2 millimeters, which is on average about a half a degree, and they can hear a change. And I say, well, I don't doubt you can hear a change, but that's not SRA and VTA. That's changing vector forces. And there's a number of vector forces in the tone arm cartridge combination. And they're going to constantly change if you're raising and lowering that arm, right? And they will dominate. So most, I've been saying this in my seminars, and if you watch the video that on a Fremmer's panel that we took in Munich, which was a lot of fun, on the question of has vinyl playback technology gone as far as it can go. I made the claim there with Leif Johansson of Audiophile there. I made the claim that, look, cartridge manufacturers are way too high. On average, 9 degrees, 7 degrees at minimum, too high. And I laid out the claim that you shouldn't be adjusting your arm height in order to optimize SRA VTA. And he agreed. But then the next question is, well, why is it that way? Why are cartridge manufacturers so high up? And so I had another hypothesis, which he also agreed with. And that is, well, most people don't use a Wally skater. Okay? Most people play with vinyl don't use a Wally skater. What a Wally skater does is it measures horizontal torque force and static friction in the vertical bearing, right? And that's really important, because when you can get your anti-skate set perfectly and confirm that you do not have excessive static friction in your bearings, then that precious little cartridge damper, which sits between the rear pole piece and the coil former, that precious little damper isn't subject to asymmetric compression. Now, because a cantilever is 6 millimeters long, and because the distance from the pivot point to the end of the coil former is about 1 millimeter, that little precious damper is subject to a 6-to-1 lever arm. So for every 1 unit of errant horizontal force on it, you got to multiply it by 6 on one side of the damper and minus 6 on the other. So the damper very quickly starts to run out of juice, and it won't be obvious to you that things are really bad for the damper until you start to hear sibilance and mistracking. Now, here's my point. Sibilance and mistracking are almost never a cartridge problem. Almost never. They're almost always a tone arm problem. The tone arm's horizontal forces are out of control, and the damper is squealing for mercy, right? And so this is why the Wally Skater is my most important tool by a long shot. I've solved more problems with that tool. So what do cartridge? So since most people aren't using a Wally Skater, and cartridge manufacturers don't like to get complaints about how their cartridge is throwing off sibilance and mistracking, and their last cartridge didn't. Never mind that your last cartridge was like a sedan, and now you just bought a race car with a nice tight suspension. But forget that little small point, right? What can cartridge manufacturers do to avoid these complaints? They take that cantilever angle and they raise it. And by raising it, they've increased the downward vector forces that assist the stylus to remain in contact with the groove. Okay? It's a cheat. It's a total cheat to get ignorant tone arm users from complaining. But we don't know what we just lost. Because if you could hear it, when it's 7 degrees back down, 9 degrees back down where it needs to be, you would not give that up. But if your arm is out of control, too much anti-skidding force, not enough anti-skidding force, or the bearing friction is too high, well, it's just going to sound, it's going to probably sound worse. But I want to have my cake and eat it too, right? I'm not interested. If I can measure it, I'm going to measure it, and I'm going to optimize it, right? So, and by the way, SRA and VTA, they're not at all the same thing. VTA is sensitive to vertical modulation, and SRA is sensitive to horizontal modulation. And I'm actually, for those, maybe those of you, some of you who watched my series on the 7 alignment targets of analog optimization, I have one more video to publish. It's currently in editing, and it's on SRA. And in this video, you're going to hear me say that I'm not convinced that SRA is nearly as important as VTA at all. And I'm going to give some reasons why. And anyway, if we have time and you're interested, I could go with that. But so the average cartridge is 9 degrees wave optimally aligned. You know, I've analyzed several hundred cartridges now. I put them all in my database. I can see on average what how every brand is doing, how the industry is doing. And I can say with extraordinarily high degree of statistical confidence that you guys, if you're playing a cartridge, you needed to get down more than 3 degrees. Okay, but many of you, like if you're using a Koetsu, for example, big wide body, you might not be able to get more than 3 degrees, 3.5 degrees, right? So you just take what you can get. But don't do that with your arm. It won't sound the same, not even close. Yeah.
JR, can you specify when you say get down more than 3 degrees exactly what you mean with respect to the tone arm position or geometry, please? Thanks.
Yeah, let me show you. There. That's 9.4 degrees. Down, butt down. Are you guys seeing that picture?
Yeah.
Okay. Yeah, that's 9.4 degrees. I mean, this is a good sounding cartridge no matter what. It's better like this. Now, I can't get, not all Hanas, I get down that far. I've gotten one down more than that. But this is about 9.4 degrees. I've gone down as much as 10. The beautiful, one of the many things I love about this cartridge is that it has a body that allows you to correct when you need to, right? So, yep, that's what that means, butt down. Okay. So that's why I've got these little shims, you know, look, you want a 4-degree shim? I got them made in this material. If you want it done in brass, I could do it in milled brass too, but I got them ready to go in these cured resin. Okay. Let me go to the next one. You know the rule about 8 hertz and 12 hertz, the cartridge tone arm resonance rule needs to be between 8 and 12 hertz. We've heard of that, all right? All right, well, I can get on with the 12 hertz. I can't get on with the 8 hertz. I think that 8 hertz lower limit is too high, and it's hurting us from getting better sounding records. Significantly so. All right. So I'm regularly taking my arms, my customer's arms, when all the conditions are right, closer to 6, sometimes 5. Right? Now, why? Why is it a bad thing? All right. So the most precious location in the cartridge, tone arm, turntable apparatus is the location of the pivot point of the cantilever. That location, you want that to remain immeasurably still, so that the only activity it sees is the movement of the coil around that point. Okay? The only thing we want that location of that pivot point to do is follow the mean position of the groove. That's it. But as soon as if we allow the pivot point of that cantilever to be modulated by the groove content, then we have by definition created mechanical distortion. We've lost information and we're creating new information that is only a second order, third order relationship to what's in the groove. Okay? So how do you do that? How do you keep that point in that location immeasurably still? Well, this is where Newton, I invoke Newton, and force equals mass times acceleration. Okay? So the heavier we make that apparatus that is holding that point, and what is that apparatus? That apparatus is the cartridge body, it's the head shell, it's the toner, right? The more massive that is, the more difficult it is to move it, right? The more rigid it is, the more difficult it is to excite it into a resonance. And by the way, the more rigid a body is, the higher the fundamental frequency of the resonance. And the higher the resonance, the easier it is to damp out, which is a nice little side benefit, right? So we would want to have that location immeasurably still. So that's why I'm telling my clients, don't be afraid of mass, don't be afraid of mass. And I'm bringing the mass up and up and up. Okay, so what do we need to be concerned about if we're going to start increasing the mass? Well, at the risk of oversimplifying a bit, let's think about eccentricity. All right, eccentricity occurs on at 33 RPM, slightly more than half a hertz. All right, that's far away from 6 hertz. We don't have to worry about that. Exciting the fundamental resonance of the cartridge tone arm union. All right, how about warps? Well, there's 2 types of warps. Of course, there's the concave or the convex warps, and then there's the radial warp. I'm not worried about concave or convex warps, but the radial warp, which acts like a speed bump, so that's the one where you see your cartridge going like that once every revolution. All right. Well, that too has a frequency of a little over half a hertz at 33 RPM, so that's not a problem. But the angle of attack of that warp can be a real problem. How quickly does that speed bump occur, right? That can set the system off into resonance. But my point is to everybody who will listen, we don't need to live with warps, so don't live with warps. I mean, if you've got vacuum hold down, great. If you've got an edge clamp, great. Record flattener. I love my record flattener. I will never give up my record flattener. This is one of the best tools I've got, right? If I got a warp, I can get 90% of it out in one go. So if you agree, I'm not going to live with warps, I'm going to do something about them, then you can improve, generally speaking, improve the quality of your sound by adding some mass. Rigid mass, by the way, not just like a glob of blue tack or something to the top. It needs to be rigid mass. There are other little provisos there, but I'll just leave that up. But anyway, so I think that for the future of analog, we're going to see less and less emphasis on this 8 hertz thing. 8 hertz was great for mom and dad's, basement a turntable where we didn't take care of our records and we didn't do anything about warps, but it's holding us back from getting better performance because we're going to want to deal with these lightweight arms and lightweight systems, but force equals mass times acceleration. It's easy to push around a tone arm that's light, low mass. Very easy. So I've got a product right now actually in beta testing. It's a replacement to the Kuzma headshell, and it does a couple things that's different from the regular Kuzma headshell. But one of them is it adds a lot of mass, and oh boy, I mean it's an obvious sonic difference and improvement by which I mean improvement. What you get when you increase the mass and reduce the ability of the groove content to push around the tone arm, you get the bass grip is just so much better. It's just so much tighter bass. Overall clarity improves, separation of instruments improves, and it just sounds more like you're listening to music and less like you're listening to a stereo. You're going to hear me use those same adjectives for a lot of these parameters because this is mechanical transcription after all, right? And while you can fit a small enough square into a round hole, it doesn't fit very well. It certainly doesn't come in contact with all the grooves well. Similarly, if you've got a fine line contact stylus, which is a facsimile of the cutting stylus, but if it's oriented in the groove in a fashion in one of the four angles that is different from how it was cut, you're going to lose out on those very same characteristics: clarity, separation of instruments, soundstage size, and that sense of ease and relaxedness, right? So, and this is, Jack can increase the mass by using those wedges you showed. Yeah, Steven. So the resin, the cured resin ones that I've got, these only add about 1.3 grams, but the brass ones add 6 grams, these brass ones, all right? But add more than that. 6 grams is not, in my opinion, it's a step in the right direction, but I'd go even higher on most systems. Yeah.
Ask a real quick question, JR, along those lines. So some of us, have Riga or SME style tone arms where the head shell is not detachable, as you know. So that's why I kind of asked the question about the wedge that could go between the head shell and the cartridge body in terms of getting that effective mass that you're referring to as a solution for that.
Yeah, yes. Yeah, well, like, so if somebody, and I've had many people with Riga arms send their cartridge to me for analysis, but one thing I have them do first is using the Wally reference, the 2 blades on it, measure the error of the head shell, right? Because then I can build that error. Because this thing, I've never heard of well, maybe a couple times, where the Riga head shell, where this is on the azimuth, where it came down flat. It's almost always got some error to it. So then with the feeler gauges, they can measure the error, and I can build it into the corrective shim, right? So, and then yes, then we can add, say the brass shim is going to add 6 grams. If you wanted to add even more mass than that, you might use like Peter Letterman has these big thumb screw 12 millimeter 2.5 millimeter screws. Yeah, yes, yeah, and just I highly suggest people start experimenting with that, right? Don't be afraid of that. Now, there are other things that can set off the fundamental resonance of cartridge tone arm. Like if there's sloppiness in the mastering room, there could be low frequency energy in the groove. That can happen. That can happen. I mean, if even there is a couple of records where I sense that you could even see the effect of people walking about in the control room or something happening because it's intermittent. This low frequency energy comes into view and then leaves, and then comes into view for a while and then leaves. I don't know. I'm just hypothesizing. So yeah. Now, next thing.
Yeah, a question. Yeah, so when you add mass, you're changing basically you're basically forcing well, more compliance, right? What does that mean to the selection of the cartridge?
Okay, so first of all, I just want to make it clear. I'm not saying increase your vertical tracking force, right? Yeah, I'm definitely. I just want to make it
Oh,
clear.
okay. So you balance it.
Oh, absolutely.
Okay.
Yes. Got to keep the vertical tracking force clear. But I'm going to make a comment about that in a moment. But yeah, we're not talking about changing your vertical tracking force. We're just changing the effective mass of the apparatus of the cartridge tone arm system. Okay.
Got it.
Much of what I say doesn't apply to high compliance cartridge. All right. I've seen some behaviors from high compliance cartridges that mystify me, and I don't have an answer for. Like, for example, when I went to Greece, and I wrote a blog article about that. I went to Greece for 28 hours to spend time with a guy who makes lathes and cutter heads and is considered an authority on such things. And he had set his anti-skate force using one of those test records, which I'm constantly lambasting, right? And so I said to him before I measured, I said, oh, that's going to be way too high. It wasn't. That's the first time I'd ever seen that, ever. Of course, he's got a really high compliance cartridge. How did that play into it? I don't know. I don't understand it yet. But it's the only time I've seen that my rule was violated, right? So there's something I don't understand. So I want to make it clear that I don't speak for high compliance cartridges, because now suddenly my world's been shattered with high compliance. I state with very high confidence if you've got medium or low compliance, which most of us do, right? Engineers, they've got a history of sticking with these high compliance cartridges, in large part because it is commonly believed that that's the one way to make sure that you're not. It's one of the ways to make sure you're not damaging the lacquer while you play it back. Okay, which I think is worthy of some investigation, because I'm not convinced. But anyway, that really surprised me. Another thing about VTF, I said I'd say something about VTF. I do tell my clients that as you add mass and as you add rigidity, as long as you've got a very rigid tone arm and you've got high mass, I encourage you to go below the manufactured recommended VTF. Just keep going down in 1/10 of a gram increments, and as long as it continues to sound better, keep going. Once it doesn't sound better, the next one, you probably hit the limit. And certainly if it sounds worse, you went too far. Now, why do I say that? Well, one, and I've had some agreement with this hypothesis with couple cartridge manufacturers. The recommended, in many cases, the recommended VTF given by cartridge manufacturers is higher than it really needs to be, because few of these cartridge manufacturers have the confidence that you're going to manage your tone arm's horizontal forces, which is, again, why I love the Wally Skater. Okay, few of them have the confidence that you're going to do it. Your tone arm's going to be out of control. So the way that they can avoid complaints of sibilance and mistracking is just say, just increase the VTF. So if anybody ever emails me or tells me, look, my turntable is sibilant, I always ask them, did you double check with a calibrated VTF scale, and then did you get a Wally Skater on it? It's 90% of the time that fixes it. Right?
So JR, when I'm going through VTFs, do I need to adjust anything for VTA?
Yeah. So I've done some studies on some lyras in the past where I was able to measure what's the angular change on VTA when I change the VTF by 1/10 of a gram once I'm above a certain level. Like, who cares about the angular change between 0.4 grams of VTF and 0.5 grams of VTF? You're not going to play that low, right? Well, as you approach the manufacturer's targeted VTF, and you add or subtract and tenth gram increments, the angle changes very little. And but it's a good question anyway, because let's say, because technically, as you decrease the VTF, you are going to be increasing the VTA. And I've already gotten done telling you all, get your VTA down. So, well, this is a situation where you're going to have to use your ears, because you're changing a minimum 2 variables at the same time. Well, there's more than that are changing when you change VTF, but you're going to have to use your ears. What sounds better, right? And you keep going down in tenth of a gram increments, and once it's not continuing to sound better, you just stop. Don't go any further. But as you decrease your VTF, you're likely to have to reset your anti-skating, right? Because anti-skating is always applied as a percentage of your VTF, right? Did that answer your question? Well, I kind of answered your question, right, Fred?
Yes. So in principle, I could calculate the change in height from the change in VTF with the compliance.
Yeah, but the compliance, it doesn't appear to act in a
I
linear
have to
fashion.
do some geometry.
Yeah, it doesn't appear to act in a linear fashion. Yes. And, your starting cantilever angle, the higher the cantilever angle, the greater the change.
Now, that might be a place where raising and lowering the pivot actually is appropriate. It doesn't have much range, but I don't need to get you to make a new shim.
Yeah, well, then you're going to be having to, look, go ahead and use your ears, but when you lower that arm, you're also going to be changing a number of different vector forces.
Right.
Well. So, use your ears on that one, because the world of these vector forces is very, very poorly understood.
Can I just add a comment to that really quickly to expand on Jerry's point? He's absolutely right. And I don't want this to come across in the wrong way, but engineering is often taught called OFAT, one factor time analysis, okay? What JR is speaking to is that there is an interaction between these control factors and the response of the cartridge to its geometry. And what the Wally tractor and the other Wally tools do is let you optimize the interactions between these various control factors to obtain the optimal geometry. It's not a simple thing like VTA or this or that. It's the interaction of these control factors that results in the optimal setup.
Mm-hmm. Yeah, and it's a complex world, right, Stephen?
Yeah,
and I
absolutely.
can understand how people have, well, one, just don't have the patience to try to get to the bottom of all of it so that they can. Well, that's why I make these videos. I'm trying to articulate in the best, simplest way possible some rather complex ideas, and they need to be articulated in a manner that's useful, right?
That's absolutely right. And just to expand on that, key principle in chemistry for any chemical reaction is time and temperature. But when you go to university and they train you in one factor time analysis of science, they say, take the knob for temperature, set it to X, measure, set it back to 0. Take the knob for time, set it to Y, measure, set it back to 0. But many, 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 many chemical reactions have a time-temperature interaction. You can't get away from that. And that's that interaction that drives the response we care about, right? That's exactly what JR is talking about here.
Yeah, so my approach it's a parametric approach. I want to be able to control each of the parameters that we know influence our performance separately as much as possible, right? Now, we cannot impact SRA separately from VTA. They're in a locked relationship unless you expect to unglue that stylus and remount it at a different angle, which I don't recommend, right? So I'm doing my best to create a system that is parametric. We can then focus on, all right, if we can measure just this one parameter, what is optimal for that parameter? And how do we allow people to nail it, right? Okay. There's people will often, and we're still seeing arguments on it on forums all the time, but arguing for one alignment schema versus another alignment schema, Lofgren or Bearwald or Uniden or Stevenson. oh, 9-inch arms versus 12-inch arms. I see this argument other, well, 12-inch arm is better because the tracking error is much lower. And while this is true, it's a total misapplication. It's not a misapplication. There is a problem of lack of perspective, okay? Because the only reason why we'll aim for those of us who use fine line contact styluses, which is most of us, I would presume. The reason why we aim for better alignment with our cartridges or a longer tone arm to get better tracking error is to get the left contact point and the right contact point properly oriented in the groove. But the degree to which this stylus is mounted to the cantilever is highly variable. And there's only 3 companies that do these, for the most part, in the high-end world. And their tolerance is plus minus 5 degrees. So you've gone through the extra expense and money of getting a tangential tracker. Good for you. You got 3 degrees of zenith error on average. How do I know that? Because you have a Japanese stylus. It's about 3.1 degrees on average in error. So now you might as well have everything off by 3 degrees all the way, because you're not going to hear everything that there is to hear. Will it sound good? Yes, it will still sound good. I'm not saying it'll sound bad. I want to make that very clear. You can be perfectly misaligned in every parameter in analog, and still it sounds good. It's a forgiving medium. But it's a mechanical certainty. You will not get everything that there is to get out of the groove if things are not optimally aligned. So when people ask, well, I'm gonna have to go for a 12-inch arm because I can get, about 0.36 degrees improvement in tracking error, which, by the way, is in a small playing area of the record, by the way, just a very small playing area. Well, good for you. But have you checked out what your zenith error is and corrected for that first? Because it's just not, because zenith error is 10 times greater magnitude, almost, than what you're arguing over. So yeah, that's another bit of source of irritation for us. Yeah. Yeah, at this point, in any questions? No.
I don't have a question, JR, but again, you and I think, know each other well enough to know that we think along very similar lines about things, right? And I think what you're speaking to, which I really resonate with, is the fact that this is a system. And when you teach systems engineering, there are control factors, there's a functional response, and then there are noise factors, right? The noise factors influence the settings of the control factors to take the functional response off target. And what I really resonate with what you're talking about here is you have to approach this from a systems engineering perspective and understand you've got to determine the optimal setup for the control factors to produce the ideal functional response in the context of operating in a world of noise factors. And that's, I think, is a very powerful philosophical understanding. So thank you for that.
Yeah, you're welcome.
So JR, we're about 45 minutes or so into the talk, maybe, half, a little bit more. I just want to make sure you have time to talk about the acoustics and bass propagation part,
Yeah,
but
sure. Yeah,
Can I ask one question?
I'm not trying to move you off of the analog side. I would listen to that today, but I'm just.
No, I can always come back to the analog.
So, Jared, can I ask a quick question before you move on? You didn't say this explicitly, but my implication is you still believe a level tone arm is best, but you should adjust for SRI VTA using shims, not by changing the height of the base of the tone arm.
Definitely. But I won't go so far to say as don't play with your tone arm height to see if you can't find some additional subjective improvement. But what I would say is first do your best to optimize your VTA at the head shell. Then later, once you've got that dialed in, if you want to play with arm height, go ahead, but be sure to remeasure your VTF after every change in tone arm height. because that's one of the vector forces that will definitely change. More
Great.
on some arms than others. Okay? Because you want that to remain constant. You want at least your VTF to remain constant between your subjective trials. Raise the arm 2 millimeters, reset the VTF, listen again. Right? Yeah.
Thanks.
Yeah. And some arms are extraordinarily sensitive to Tonearm height and VTF changing. The Kuzma 4-point design, very sensitive. In fact, I can raise my Kuzma 4-point all the way up to the top and never change VTA. And I'm exaggerating a little bit, but it almost changes not at all. Why? Because as you raise the arm, VTF increases. So the arm's going higher, and you think VTA should go higher, but because the VTF is higher, it's pushing it back down. Right? And so a unipivot, because that's got the center of gravity below the horizontal pivot of the arm, will work in the opposite fashion. When you raise the arm, VTF will go down, not up. Okay, so the vector forces are inverted on that relationship between the center of gravity and the horizontal pivot point. So yeah.
Could you say a word about whether or not the tone arm is level and whether or not the pivot point is at the same height as the stylus contact point?
Yeah, well, what's more important, that it's at the height of the stylus contact point or the height of the cantilever pivot point? I would argue that cantilever pivot point is probably more important vector force, but I don't know yet. But Fred, you were asking me to make a comment about, so
if I have, okay, so where do tone arms normally put their pivot point with respect to the record?
Yeah.
And can I, ideally those should be on the same plane.
I agree.
And if the designer of the tone arm has not put them on the same plane, do I win if I actually make the tone arm not parallel so that they are on the same plane?
Yeah. Yeah, so he is absolutely right. The vast majority of tone arms have the horizontal pivot of the arm. Now, horizontal pivot of the arm offers vertical freedom of the arm. And in most cases, that point is higher than record level. Record level is down here. In most places, most tone arms, you can see a direct downward relationship from the pivot of the arm down to the stylus point. Well, that means as friction increases between the record and the stylus, VTF has a tendency to decrease. Now, there is one arm that has the pivot point below record level, specifically in order so that when friction increases, which happens on high amplitude tracks, which is the part of the tracks we're more likely to have sibilance and mistracking at, when it sees more friction, it actually increases the VTF a little bit. Now, if the pivot of the arm is at record height, then it will not change. The VTF won't change regardless of the drag force, right? So I think that's one thing that's what's distinctive about the Kuzma 4-point design and the Supatrack design. Those two arms have the horizontal pivot at or below record level. And it is interesting to note that the sonic characteristic that they both share is that sense of drive and authority, right? What can we glean from that? Maybe not much, right? That's not much of a data set, but you can have an arm like the SAT arm has. Well, the SAT arm doesn't even have the sense of that drive and authority that even the Supatrack does. The SAT is a beautiful, beautiful, beautiful arm, but I'm not taking away from it, but it's different. Yeah. Did I answer your question, Brad?
So if my tone arm has the pivot point well above the record surface, then if I lower that pivot point, that will put the cartridge butt down,
Yeah, well,
which cartridges normally want. And
correct.
is it better to operate it with the tone arm not parallel to undo the bad thing that the manufacturer has done?
So I think it depends on the tone arm design. You know, some tone arms will just sound bloated when you get it down too far. And I don't even fully understand the reason why that is.
Thank you.
Yeah.
JR, we have a question from the audience. Is there an instruction manual for the starting point, what to check first, all the way through to finishing optimization of the cartridge and tone arm?
Yeah. So yeah, if you go to my website, wallyanalog.com, there's a video page, and the video page is organized into sections, and at the top is like the start learning here section, and then it goes a little bit more advanced, and then deep dive videos down below. So it's a whole page of informational videos that should be pretty educational for you. In addition, the Wally School, which is the blog, will have some interesting reading as well. Let's talk about acoustics, bass propagation in particular. So acoustics, the way we experience sound can be really separated into two regions. There's the statistical region of acoustics and the modal region of acoustics. Where one starts and one stops is not hard drawn line, and it has to do with the size of the room that you're experiencing the sound in, and your distance from the propagation points. But for us in the audiophile world, it's somewhere around 160 hertz up is the statistical region, and 160 hertz down is the modal region. All right. Now, I don't consider myself an expert in the statistical region. I lean heavily on Norman Varney, who I know has been a guest here and is a wonderful acoustician. I've learned a lot from Norman. And so when I go to clients and we work on acoustics and such, I'll often call Norman with a question to try to get things dialed in. My area, but I'm happy to talk about that region. But when I hit the limit of my knowledge, I'll certainly say so. The bass region, however, the modal region carries a lot of interest for me, because the way we experience sound in the modal region is very different from the way we experience it in the statistical region. The statistical region, again, about 160 hertz on up, we know about these things like the first reflection point and secondary and tertiary reflections around the room. We know about absorption and diffusion. We've heard about these things, and controlling the reflections. In the modal region, it's why it becomes so interesting is that the wavelengths are so long that they're often longer, and usually longer than the distance from the speakers to your ear. So by the time the sound has left the speaker and has arrived at your listening position, that's called time of flight, one full cycle at, let's say, 80 hertz hasn't even resolved. It hasn't even resolved to 360 degrees yet. It has to go past you, hit off a surface, and come back for you to hear it. And then you need a few cycles to hear pitch. Okay? Now, I'll get back to something called acoustic coupling in a moment, but so this is why bass can never be time aligned in an open room. Now, one would say, well, why is it that I can hear bass from headphones? Well, that's where acoustic coupling comes in. There's excellent acoustic coupling between the diaphragm and the air pressure in my eardrum, all right? And because of that acoustic coupling, we can hear bass when it's close up like this. But when sound has been propagated into free space, and it's free space until it hits the boundaries of the room, the acoustic coupling is rather poor. If I take a speaker and hoist it by a crane 100 feet up in the air, and then I take a second crane and hoist you up 10 feet away from that speaker, and I play low bass, you'll hear next to nothing until the bass hits the ground and comes back and meets you. Because you're too close for one full wavelength to even resolve, and the acoustic coupling is garbage. There's just no acoustic coupling up there, right? But if I were to pay 1,000 hertz signal, you'd hear it quite nicely, right? So we need the room to hear bass, okay? Well, that has a whole lot of implications. One, bass will never be time aligned. It can be phase aligned, but that's something different, okay? Two, we're going to hear bass arriving from multiple different surfaces at different times. And this is why we get modes, and we get such uneven frequency response. And you move your head 6 inches this way and it's different. You move your head 10 inches that way and it sounds completely different, right? Because there's these pressure waves going through the room, and because the room itself isn't changing dimensions, those pressure waves, those waves of high pressure and low pressure are building up, assuming you're loading the room, let's say with white pink noise. They're building up and they're kind of staying there. Okay, here's a high pressure zone, and over here with my left arm, there's a low pressure zone at the same frequency. Well, this makes for really tough control of the bass, because it completely gives control to the room. When the speaker designer goes through all the effort to design the flattest speaker in the modal range, or a subwoofer that's wonderfully flat and goes down to whatever, 15 hertz or whatever, my comment on that is, good for them. That works in a quasi-anechoic response. But once you get into the room, all bets are completely off. They have plenty of control in the statistical region, but they have almost zero control in the modal region. I'm a proponent of asymmetric distributed bass arrays, which is you propagate bass asymmetrically in the room with 4 small subwoofers, right? And then they each have to be tuned, different crossover points, different phase relationships, et cetera, et cetera. So one of the first ones I ever put in was in a room, a tiny little room, 13 feet by 12 by a little less than 8 feet height, real small. And the subs were only quasi-anechoic rated. Their 3 dB down point was at like 26 hertz. Once they had that installed, our 3 dB down point was almost 15 hertz. Why? Because the room dominates. The speaker designer doesn't have much to say. Okay?
Again, what you're talking about is the interaction between the sub and the room itself in producing the response that we're hearing.
That's right. And it's not just the dimensions at all. Here's another case in point. A client in Mississippi put a distributed bass array. Now his listening room is a former like elementary school classroom from the 1950s, right? It's got a wood floor and wood structures, high ceilings, and big beautiful room, but it's got a spongy floor, right? Real spongy floor. Well, we got bass array put in. The bass was plus minus 2 dB down to about 18 hertz. Decay time, I mean, it was lightning fast, 350 milliseconds, all the way down to 20 hertz, in less than 30 dB down in less than 350 milliseconds. It was great, but I left him with instructions. I said, this floor is really spongy, and I think you would really help performance if you put some floor jacks underneath there and stiffen up that floor. Well, when he finally got around to it, it completely obliterated his bass response. Now, what happened? He changed the rigidity of one of the 6 surfaces. And it completely, he had said, I have to turn off the bass array. It wasn't working anymore. I had to go back and retune it. But here's the point. You know, we got all these clever software we can download and plug in the dimensions of our room, and it's going to tell us where our room modes are. And I say, to hell with all that. Those calculations presume that you've got an infinitely rigid 6 surfaces, you've got no apertures, you probably have got no contents in the room. Where are you propagating from? Where are you measuring from? And so you know, here's my point. Please don't waste your time. Those very limited value with those calculations, extraordinarily limited. Sometimes they'll tell you something that actually measures to be true. More often than not, it's not very useful at all, right? There's nothing that takes the place of in-room measurements, particularly in the modal region. There's way too many factors. It's far too complex, right?
Can I share a couple of graphics to expand on what you're saying just for 1 minute or so, real quick?
That'd be interesting.
Okay, cool. So I'm going to, JR knows that when I integrated my REL subwoofer into my 2-channel mains in my small room, I used a statistical technique called design of experiments, which lets you, with statistical rigor, examine multiple control factors simultaneously and determine the optimal setting for the response that you want. Okay. I shared this with JR. He was one of the very few people, as soon as I showed him, got it immediately, which just indicates how sharp he is with respect to his domain expertise. But I'm just going to show you what I did with my REL, which has 2 control factors, gain and crossover. Okay. So design of experiments, basically, let's see if I can share. I'm going to have to share multiple screens here. So what I wanted to basically emulate was the Harmon curve. Okay, so I just did this recovering from back surgery. I was just doing this for fun with my REL. I was basically going to see, can I emulate the Harmon curve, which is a psychoacoustically derived curve that allows us to hear effectively in the real world what we perceive as a flat room response. Okay, and this was developed over the years by Harmon, where you have to have this bump here to kind of perceive a flat response. So let me stop sharing that real quick. And so I did this design of experiment real quick here and basically share this real quick. So I did this in jump. Sorry. Yeah, I did this in jump. And basically what this told me with statistical rigor was that the gain was the most important factor due to what's called the leverage plot here. The crossover had a minimal effect, but there was borderline statistically significant interaction between gain and crossover. This model was statistically significant with a p-value of 0.016, which is way significant, as JR knows, and it had an R-square of 0.97 and R-square adjusted of 0.95, which means that the data, 97% of the residuals of the data fit this model, which means it's a pretty freaking good model, okay? Now, to speak to what JR was talking to a little bit, there's an interaction here between gain and crossover, which you can see in the interaction profile. These things converging means that those 2 control factors interact in the room to produce the room response. So one last slide real quick here, then I'll let JR take it over. Let me go back here real quick. The blue trace was with my right channel speaker prior to the DUE I did to optimize the actual in-room response measured with a NIS traceable microphone at the reference position. Okay, that was the actual in-room response. After I did design of experiment, you see in green the actual in-room response, and you can see the green pretty well emulates the Harmon curve with respect to the actual in-room response measured at the listening position with a microphone at the height of my ears, right? So that's overall, I think, a pretty decent result, real world, in my room at the listening position. My point here is that to expand on JR's comment, which is really bang on the money, there are ways with statistical rigor to do this, okay? And of course, you have to verify it by listening, but the points of physics that JR is discussing cannot be overlooked. And there are tools that let you understand the interactions of these factors, the room modes, the wavelengths, all of that to get to a response like you saw on the screen there.
Yeah.
So Stephen, will that software also plot the phase response as well as the magnitude?
If you have the data, it will. It's just all jump is a statistical program. It just plots data. Okay, but it will also design DOEs for you. And I just did a really simple design of experiment, crossover and gain, right? 2-factor, 2 levels, high, low, right? And I just wanted to see, hey, could I use design of experiments to get close to the Harmon curve, right? I did this recovering from a back operation, right? But you can see I got pretty darn close. That's actual in-room response measured at the listening position, real world, not in an anechoic chamber, blah, 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 blah. That's at Stephen's listening chair, right? So
very nice.
Yeah, and so, but I want to try to make, so we've been, thank you, Stephen. And that is really interesting. And you know, the stuff you've shared with me in the past, I'd love to have some more time to dive deeper in that. But what I want to try to make it, what we're sharing here is useful, right, to the average Joe, right? Because we can talk about how everything's messed up and the common narratives don't really work. But okay, fine, JR. So what do we do about it, right? Well, and some of what I'm saying, some of it is self-serving, right? Yeah, I go around and I help people, I do this. But I'm also, I'm trying to raise the overall level of awareness so that there can be made a solution that is easier, better, cheaper than having me come to your place and optimize it, right? And we don't do that without talking about it first, okay? So what I would like you, when it comes to talking about bass response, what I would like you to walk away with here is that it's not as simple as the manufacturers are making out to be. And it's never just the frequency that matters. Time decay is really, really, really important. How long, once you've put in a low frequency impulse into a room, how long does it take for it to decay quickly, right? So most of us live with very long decay times. And we don't know how that's smearing our mid-range. And it's amazing how it smears our mid-range and shrinks our soundstage. This is one of the things that people get asymmetric distributed bass arrays will note, like, why did the soundstage just grow? Well, I don't fully understand that either. But it is remarkable to me how problems in the modal range, in this case, long decay times, modal waves in the room, will completely influence results in the mid-range. Actually, it goes the other way around as well, as I recently learned going to a client in Asia. He had a huge, beautiful, dedicated room, which he only had diffusion in, no absorption. So the decay times in the room were enormously long. And I'd gone there basically guaranteeing, look, what the distributed bass array, I can get decay times in the bass less than 350 milliseconds. I couldn't. 420 is the best I could do. And I was tearing my hair out. Really, why am I not getting the results I know I can get? Well, it turned out to be because the decay time in the nearby statistical region was too long. I'd left him with some instructions to put in a lot of absorption, and he put in at least some of it, and he said the bass got tighter. It's like, oh, great, because I assumed that might happen, then to hear from him that indeed it did happen, because he took care of the mid-range decay times. The decay times in the bass were actually influenced. There's so much we don't understand. Well, look, let me speak for me. There's so much I don't understand, okay, about why this works the way it does, right? I'd love to understand the mechanics of it, but a lot of it remains a mystery. And I just know that that there's a lot more that we can influence than we let on. And the prescriptions given by many of the manufacturers are way too oversimplified. All right. Please don't put subwoofers in the corners. Please, dear God, don't do it, because then you're guaranteed to exacerbate every room mode that your room will produce. Yes, will it give a lot of gain? Yeah. Additionally, tower speakers. They're gorgeous, they're lovely, they're sexy, and they're certainly awesome. But by propagating bass symmetrically in the room, as tower speakers do, it guarantees that both propagation points will exacerbate similar room modes. Which is why I am a big proponent of just, if I'm designing a system from scratch, I say, buy the best speaker you can that does 150 hertz on up. Don't worry about the bass. You don't want it to play bass. We'll take care of that with an array, right? At least that way, we've got control over frequency, we've got control over time. And I don't even need DSP, by the way. DSP makes it a little easier, but don't need it,
JR, this may be asking you to generalize too much, but given that you just mentioned don't put the sub in the corner of a room, is there a general place where you found overall that placing the sub works in the widest variety of setups or applications? The reason I'm asking this is I've seen John Darko do some videos with a small KEF subwoofer, and he's pretty much got it down on the floor between the two mains, kind of in the front of the rack sometimes, and I'm just wondering, how do you determine where the optimal placement within a room might be?
Well, so if the question is for one sub, my answer is I have no idea.
Okay.
None. Zero. Zip. I can't think of one. If I only have one sub, I can't think of any one optimal place to put it. Right? When I put in 4 subs, the room will tell me where to put it because I measure for those locations. I go around on my hands and knees and measure around. Invariably, one location will be within 2.5 feet of one of the main speakers. Invariably, one of them will be somewhere along the front wall, but not dead in the center, somewhere just off either the left side or the right side of center. And then the others will be somewhere, maybe even higher up. I'll measure around. Wherever I got a place to put a subwoofer, I'll measure, tell me, where is it telling me is a good place? Because the whole point is that if you've got 4 subs, each acting in independent locations in the room, and they're adjusted well, then not one of them, no 2 of them are upsetting the same room modes in the same fashion, right? So each one is doing a portion of the work, but interacting with the room slightly differently. And the other side benefit is that this is that when you put in one of these bass arrays, bass sounds pretty much the same wherever you are in the room, even when you're standing close to a border, a boundary. Yeah, thank you. Yeah, so yeah.
JR,
There was a question, yeah, Jim.
I have a question. So when you were doing your process with the bass array, you mentioned that you adjust the crossover for each bass after you've done the measurements. So obviously you're using an active crossover for the 4 subwoofers.
Yeah.
Correct?
Yeah.
And is this a proprietary type of crossover, or do you use kind of a off-the-shelf?
Oh no, yeah, off the shelf. I mean, I've had clients who've got 4 rhythmic speakers, so I adjust each one differently. I've had customers with 4 SVS speakers, adjust each one differently. I prefer to work from one control unit, so given the option, I would use something like an Ashley Protea crossover unit, and then that goes to a home theater multi-channel amplifier, and then that pushes 4 subs. But each sub will be at a different crossover point, for sure. Because sub number 1, when I watch how that interacts with the room, it might be very effective for the first 2 octaves, but it does almost nothing above that. So I'm not going to ask it to do anything above that, because it's also going to start to cause, it's going to, without providing any benefit in those frequencies, it will still interact with the other subs, right? So, but then another one will do, say sub number 2, will do nothing in the first octave, but will be very active from, let's say, 40 to 90. And so we see what do each one of them care to do, and I don't try to fight them, right? And then I got to still make sure that they're both, all of them are pretty much talking at about the same level, but they're not all working with summation. There's cancellation. So it's not like each sub is doing 25% of the work. Each sub is doing more than 25% of the work, but a lot of the work goes into canceling what some of the other subs are doing.
Do you find some rooms allow you to get the kind of bass response you would like to get with less than 4, and some rooms might even require 5? I mean, if you have a room that you might be able to put 2 or 3 at different places, and you're getting they're just working in that room.
The only occasions I've ever been satisfied, and remember, I've got very high bar of satisfaction.
Sure.
Right? Very high in terms of frequency and time decay. The only time that 2 subs ever satisfied me happened to have been two different applications where the main speakers were planar, open baffle, and open baffle in the bass as well. Okay. And by the way, in both of those occasions, the two subs were out of phase with each other, 180 degrees. Right. So generally it takes 4. The only times I'm kind of disappointed is if the room is open up to the rest of the house and it's not enclosed, then it can be really sometimes very difficult to get all of the first octave. Sometimes it'll be rolling off at like 24, 25 hertz instead, right? But listen, I would much rather take a limited frequency extent and as opposed to give up decay time. I want that bass to decay fast, very fast. I don't want to hang out in the room.
Generically, how do you balance decay time versus frequency response when you're making your measurements?
Oh, that's interesting.
Decide how I'm going to adjust it.
Yeah, so most of the time, once I've found the 4 locations of the subs, and then I have them start to work, I measure from the listening position, and I've got pink noise generator. I'm looking at a real-time analyzer. I'm going to see a ragged waveform. I'm going to see a ragged frequency response in the bass. And then I just try sub number 1, invert the bass completely. Sub number 2, invert the bass completely. Then go to 3 and see if when I invert any one of them, sometimes I'll just see a whoop, or real close to a flattening. One of them just wants to be inverted, all right? And I find out if there's one of them that just wants to be inverted to act as a whole. Then I'll start playing with different crossover points, because I see that sub number 2 is not doing anything above 90, so I don't ask it to do anything above 90. And then I'll start playing with delay times slightly, because when I delay some by say 40, if I do a delay some by about 1.5 microseconds and another one by milliseconds, another set by 3 something milliseconds, I can see a real flattening of the whole bass response. So what I'm doing first is flattening the response by playing with multiple different parameters. And then usually, once I got it flat, and then I do a sweep, wood, and then analyze time decay, usually the time decay is excellent. Why that is, I can't fully explain it. I don't really understand all the mechanics behind that. But it's frustrating though, because it's such a multivariate system. Like, let's say, for example, sub number 1 initially shows that it works really good in the first 2 octaves, but nothing above that. Now I go about and I change crossover points and I change phase relationships, and then I have to look at sub number 1 again. Is it still behaving like it did initially? And many times the answer is no. Now it goes all the way up to the 3rd octave, and it doesn't do as much of the 1st octave. It's so multivariate. It's fascinating, really. I'm constantly.
You're talking about a system where the control factors interact. That's why you're getting these responses.
They do. Yeah. Yep.
JR, when you're going to this, putting this effort in, and you're making these you're measuring and you're adjusting, does that affect the need for any particular quality or type of subwoofer, or
Yeah, that's a good question.
Or
Okay.
do you still really a better, a faster, better, whether it's
Okay,
a
that's a good
JL
question.
audio expensive one, or
Yeah,
one of the top SVSs that you can go
Yeah.
on your app and make super minor changes versus being a cheaper,
Yeah.
that, it costs $500, blah, blah, blah. You're really adjusting it. So I'll let you go on.
So I've struggled on how to answer this, and I think just in the last, because I've been asked this question many times, and my answer for a long time was, I'm not real sure what the benefit will be to pay for a better subwoofer, better equipment to power the subwoofer, et cetera, et cetera. But now I think I've got enough experience behind me, and I would have this to say. if I gave you an unlimited budget to buy 2 subwoofers, right? Unlimited, I don't care, 2 subwoofers. And we bring to bear, we do a contest. The results, both subjective and measured, with what you can do with those 2 subs versus what I can do with 4 inexpensive subs put in the way that I would like to see it put away in a distributed base array with the controls that I need for that. I'm confident that both on measured and subjective basis, we'd like this base array best. But why do I feel that it has the advantage? Well, the advantage I feel has the advantage because what I can control for is the decay time. You cannot do that with just 2 subs. Okay? But what can you control for with high, really, really high quality subwoofers, right? You can control for the rise time, the transient speed. That will be better. Now, I've not ever tried a situation where we put in one of the lower cost options in distributed base array and then put in really high-end subs and see how much better does it sound. Never tried it. But hypothetically, the expensive subs should offer a faster transient response, better, which would also mean faster stop time, you know. But they would have no advantage at all over how the room plays the impulse out. None.
Right.
That's where the array comes in.
I've had success using MSR spring traps in my room because they have that ability to diminish very rapidly the modal sounds.
Yes.
And interestingly enough, when I got a pair of subs to replace an older pair that weren't all that good, it turned out, and again, I'm dealing with a dealer who uses his ears mostly for making adjustments. That's Hugh Fountain. We wound up actually putting the subs very, very close to the rear port on my Wilson Alexia Vs, which I thought was really strange. If you go to the Wilson site, they'll tell you to sort of put it in that sort of arc.
Yeah.
You know.
Yeah.
So you never know. And then your points about the room itself and the construction of the floors and the ceilings and everything.
Yeah.
It's an art form. I'm sorry.
Well, so a lot of people will tell you it's an art. I don't believe that it is.
It's not totally an art.
I don't believe it is an art. I believe it is a science, but we haven't figured out how to understand it fully yet.
Right.
Okay. Now, that doesn't mean that some fella with the right tools and a good ear can't do a wonderful job.
Right.
But it would be real fun to measure the response and see. Look, with your spring traps, you sounds like diaphragmatic bass traps. I agree. You know, these things, well, they work, but what many people will fail to understand, and I'm not saying this is you, Steve, but what many people fail to understand when they're considering products like this is that, well, you have to know 3 things at least. What frequency are you trying to tame down?
Right.
How much surface area do you need, and where do you put them?
Mm-hmm.
Right.
Yep.
So you can turn out that you put these things in place, and they do the described. They do as advertised, but you could be creating a problem a half octave away. And unless you measure for that, both in frequency and time, you won't know. Right? But when I say creating a problem, so often it's the errors of omission that we don't notice, right, at all. Once we've lost something, it's a lot less obvious to us than if we have a problem that we can hear, right? So I prefer, wherever possible, to measure and, you know, and go from there. But I agree, Steve. I mean, that's one way to do it. I've just
Steve. Also, what you're talking about, real quick, is there's an interaction going on in your room. It's not just the subwoofer itself. Okay, it's the room modes, it's the room dimensions, it's the placement. Those are all control factors that interact. This is exactly what JR's been saying. It's not just as simple as like putting the sub in the room, right? That's where JR's expertise comes in, is determining where to place the control factors to obtain the optimal response.
JR, are the microphones that most of us use that come with Room Equalization Wizard good enough at the low end to have measurements that are meaningful?
In my experience, I've got, I think, 4 different microphones, and they certainly vary in their bass response. But for the most part, I think they're just fine. Yeah, I mean, as long as you're not expecting to design speakers with them, I think for the most part, they're just fine. You know, that I think it was Steve, you mentioned that you were instructed to put the sub along that arc, right? The arc with the center point being your listening position, right? Am I correct? That's what the William.
That's the general rule that Wilson presents to the world for speakers.
Yes.
But every room is different, like Stephen was saying.
But those instructions are based on a misunderstanding about how we hear bass.
Yeah.
They're assuming that bass is time aligned. Well, it is if you're 53 feet away from the speaker, then you can get that 20 hertz cycle time aligned. But no, you sit 10 feet from the speaker, you know, the lowest frequency that's going to be time aligned is going to be somewhere around 100 hertz.
Mm-hmm.
Okay. And even then, you're not going to get pitch. But anyway, that's beside the point. So that's a misnomer. The room will dominate how you hear in phase and frequency and time, and it is not up to the speaker designer. Full stop. Okay, they have a little bit of input. I mean, remember, case in point, those subs, which were quasi-anechoic, to roll off at 26 hertz, we got down to almost 15.
JR, so we have another couple questions in the chat area. John wanted to know, do you have any experience with open baffle subwoofers?
A little bit. I own a couple. I haven't used them in a long time. You know, the difficulty I've found with those is just getting any bit of the lowest octave. And I want that octave. In fact, I want below that. Because even on records, there's subsonic information that is fun to have. A Royal Ballet. If you don't hear the subwoofer on the Royal Ballet, you know that you're not getting subsonic information. Yeah, I've got some experience with them, but it is old experience, admittedly, and it'd be fun to give them a go again. Yeah.
For most normal sized rooms, and I'm not talking about people who have just these vast, large spaces, but most normal sized rooms, when you are using an array, do you find the size of the driver is like, if you going with like 4 10-inch drivers versus a 12-inch or even bigger, that it's easier to use a smaller driver? Or does it even make it that much of a difference in a normal sized room, as long as you are going through the process and you're getting everything lined up like you do? Can you have just, you know, in terms of achieving good bass down into the 20s or high teens, you know?
So the decision, any advice on how much driver area to bring into a given room, I actually defer to Duke Lejeune and James Romaine, who I work with often to get my clients distributed bass arrays. That's a decision that they're better with. Now, I do know this, that the larger the room, certainly the more volume you need of air you need to push, for sure. Or if maybe your room is small, but it's totally open up to the rest of the house. Well, now it's going to, in the modal region, the first octave anyway, it's going to act like a huge room. So if you want to get that first octave, even if you've got a small room, but it's open up to the rest of the house, then you need more driver. Yeah.
So we're at an hour and a half. I'm not saying we have to all disappear at the moment, but I just want to make everyone aware of the time and of JR's time. Uh, does anyone have any more questions? Do you want to go back to the analog world or anything else in terms of bass propagation, or is there another subject or another myth that you wanted to touch upon?
Yeah, I'm open to any questions.
I have to go. I just want to thank once again Jim for organizing and coordinating this, and JR, as always, your wisdom and expertise is most valued. So thank you very much.
Well, thank you very much, Stephen.
JR, I wanted to ask you a question. I have a dedicated room that's 17 by 26, and I've got two Rail Predator 1510s, 4 foot off the wall, 4 foot high, and done in quarters on the back wall. And I have two Rail subwoofers I was going to put in the middle of the sidewalls, and then up front I have two Klipsch subwoofers. So what I was hoping to do is avoid a null, but what I'm hearing you say possibly is that they will basically cancel each other out. Is that correct?
No, not necessarily. And there is, I don't think that there are any hard and fast rules at all with regard to placement. It requires an in-room measurement to really understand what's going on. Look, if you just avoid the corners and you distribute these subwoofers asymmetrically about the room, you're already ahead.
Okay.
Okay. And then try to get them so that they're each speaking into the room with about approximately equal amplitude. They do not need to be the same crossover point. If, for example, while you're playing, even just pink noise, and you can hear one sub, make sure first it's not playing any louder than the others, and secondly, try turning the crossover down on that one.
Down, yeah.
Right? You shouldn't hear any sub play at all. Right? It should just
disappear.
Yeah, I'm sorry, I'm not going to be able to there are no rules like this, especially in the modal region. And why? Because construction matters. Like if you were to change, if I were to come into your room right now, find the best 4 locations, and then you go and you, just like my customer in Mississippi, if you were to change one of your walls from wood frame to concrete, we'd have to do it all over again. All right. So meaning your dimensions aren't going to tell me anything.
Well,
right?
see, I have a cloth ceiling, and I have a foam floor, probably about 3/8 thick. It's a room within a room. I specifically built it that way.
Okay.
And yeah, so I'm thinking that's actually, I'm hoping that it's going to absorb a lot of the bass from the room, as far as evening out. So
Okay.
I don't know if it's going to work or not. If it doesn't work, I'll pull stuff up or pull stuff down.
Well, one thing I would definitely say, because your entire 6 sides, it sounds like it's all probably wood frame. I would definitely put like Norman Varney's EVPs under every one of your subs.
Okay.
Absolutely, positively, because you do not want those subs modulating the room.
Right.
You do not want to hear your construction. And if your subs are sitting directly on the floor, you are hearing your room vibrate.
Vibrate. Yeah.
For sure. Yeah. Even on concrete on grade, I've experienced this. Never thought that would be beneficial, but putting those EVPs under subs, even on concrete on grade, was an obvious improvement in every time I've heard it.
Okay.
Yeah. Yeah.
So EVPs.
Yeah, those EVPs are great. I can get them 20% off if you come to me. I know I can get 20% off. Yeah. So yeah. Any other questions?
JR, do you want to go a little bit before we go? Just give you a chance to talk about some of the services you offer. I mean, you touched upon your shims and your cartridge measurements for anyone in the.
Yeah, so one of the things that keeps me busy is the cartridge analysis. So people send me the cartridge, I analyze it for its how much correction it needs for SRA, VTA, azimuth, and zenith error. And then I create a custom shim, just like this, that I showed you before, that has in it that particular cartridge's azimuth correction and SRA VTA correction. If there's a zenith error, which 82% of the cases there is a zenith error worth hearing, then use the Wally Zenith to correct for that. I've got a video on how to install an analyzed cartridge. Yeah.
If you don't want to go into specific pricing at this point, that's fine. But I'm just curious, the metal shims, the brass shims,
Yeah.
they're approximately from percentage wise, how much more expensive are they compared to the
So yeah,
composite?
so the resin, the cured resin shims are well, these are free with the analysis, and the analysis is $495. But if you want one to play with in your rig, $125 for these, and the milled brass shim $275, which for a custom milled anything is pretty darn good.
Very good. Thank you for
Yeah.
that. And could you give me, I'm just curious to go to someone's, aside from travel costs, of course, but the general price range to go into someone's room and putting in an array and doing the measurements and spending, I mean, was it a day, 2 days, however long it takes to
Yeah. Well, if I'm having to do air travel, then I need a minimum of a day and a half. And putting in a distributed base rate is definitely a full day deal. And I charge plus any travel fees plus 2,500.
Okay.
Yeah.
Okay, let's try it again. Can you hear me now?
We can hear you now, Christopher.
Okay, so thanks for the pricing or approximations.
Yeah.
I've watched all your videos and it's helped, even though I have no test equipment. But can you, for the subwoofers, if you use the crawl to locate your subs,
Yeah.
can you use the crawl for multiple subs in lieu of measurement if you don't have the equipment?
By crawl, you mean go and put your head
Subwoofer
down and
crawl,
listen?
Yeah.
Yeah.
Well, the way I was taught it many, many moons ago was you put the subwoofer in your listening position.
Yeah.
And let it play and go around the room and find the peaks and the nulls by ear.
Yes.
So success, found a spot, place a sub.
What are you listening for, peaks or nulls?
Well, I did both, but that's because I didn't know.
So actually, that would work if you listen for the best place on the floor, then you put the speaker there, and where there's the fewest peaks and nulls.
Right. But this goes back and forth for half a day. But then I grab my other subwoofer because I have three technically. I have a dual calf, which one sub goes left and one sub goes right, and I have it angled. And then I have another old DefTech, Stone Age technology. And it turned out at right angles to the room, I got the best response. I keep debating whether to add the fourth sub somewhere in the back. Because I have the situation you described, which is an open area at the back.
Yeah.
That leads to a hallway.
Yeah.
And it basically turns the whole house into a transmission line.
Well, just I would encourage you to go ahead and put in the fourth, but just realize that when you put in the fourth, you may be forced to reset all of the settings on your previous three.
Sure.
Okay.
Go through it all again.
Yeah. And the process that I use to find the four locations, first I load, assuming that the main speakers put out any appreciable bass, I load the bass with broadband pink noise, and then I measure, I'm looking for nulls. I look for nulls. All right. And the deeper, the better. So I found I usually look, I'll usually find the first null that's really significant somewhere within 2.5 feet of one of the two speakers. Put the first sub there. Go back to the listening position, integrate that sub just volume wise. That's all, just volume wise with the rest of the system. Now redo the system, redo it. Now look for location number 2. find some candidates, choose the best candidate location, put the second sub there, go back, rebalance sub 1, sub 2 with the main.
Okay.
Do it a third time.
Yeah.
Right. And so yeah, I'm looking for nulls.
Okay.
I
So
often find them near boundaries of, like, if there's an outside corner to a room,
mhm,
there's often a nice null
no,
there.
sure.
Yeah.
JR, I think we are at an hour 45. So I am at this point, unless we have any other questions about audio myths, I'm going to go ahead and stop recording, but then if someone wants to ask some more personal questions or talk to JR about doing a service firm or something, by all means, I won't shut everyone out of the Zoom right away.